Okay, in this video we're going to be doing Calc BC Problem Set number 17. The problems and playlists are in the description below. Let's take a look. Number 1, given function f of x defined by f of x is the sum from 0 to infinity, the quantity, 2 to the n quantity x plus 3 to the n plus 1 over n plus 1 factorial. Okay. We want to find the 10th derivative at -3. All right, so the first thing that we know is that the 10th derivative is going to live in a term that looks like this. It'll be the 10th derivative at -3, quantity x plus 3 to the 10th over 10 factorial. Like, that's where we're going to find the 10th derivative. Things might get simplified along the way or rewritten somehow, but it should look like that. So the key is this exponent should be 10, which means the n plus 1 that we're dealing with should equal 10. So n that we need overall should be 9. So what I'm going to do is I'm going to just take 9 and plug it into the nth term of this series. So that'll give me 2 to the 9th quantity x plus 3 to the 10th over 10 factorial, which is what we're looking for. So all of this should be equal to this thing, the thing that we were looking at before. And now we just have to go through and solve for the 10th derivative. So I'm just going to pop that up there, right? You can like cross out the 10 factorials. You can cross out the x plus 3 to the 10th. So we're just left with 2 to the 9th equals the 10th derivative. So the 10th derivative at -3 must be 2 to the 9th. All right, let's take a look at part B. Write the equation line tangent to f of x at x equals 0, which is annoying maybe because it's not the center. If it was the center, then we would just write the first degree Taylor polynomial and be done with it. Instead, what I'm going to do is I'm going to like figure out what function this is. To begin with, I'm going to like make a substitution because everything is n plus 1 factorial and I don't want it to be that. I want it to just be n factorial. I think this is e to the x somehow. So I'm going to make what I'm going to call a w substitution. W is n plus 1. So if that's the case, then we know that when n is equal to 0, w is equal to 1. And furthermore, we know that n is w minus 1. So I'm kind of re-indexing this thing. I'm just going to rewrite it. So instead of using n, I'm going to use w. So w we know starts at 1. And then we'll get 2 to the w minus 1 because it was 2 to the n. X plus 3 to the w over w factorial. So the reason I've done this is because I think that it's e to the x somehow manipulated a little bit. So that 2 to the w minus 1, I'm going to make it 2 to the w times 2 to the -1. And 2 to the -1 is 1/2, and I will factor that out. So 1/2, and then we have the sum, 2 to the w and x plus 3 to the w over w factorial. So this is looking better. Now what I'm going to do is just rewrite it one more time. Everything to the w I'm going to pull into one quantity. So that should have said w equals 1, not n. I knew I was going to do that. It's inevitable. So I made it 2 quantity x plus 3 or 2x plus 6 all to the w. This now is definitely 1/2 e to the 2x plus 6. Now, if you look, we're not starting at 0. We're actually starting at 1. Since we're starting at 1, we must have subtracted off the first term. So the first term we would get would be what would happen if w is 0. If w is 0, we would just get 1. So minus 1. That's the function we're dealing with. Now I'm going to actually do the problem, which is to write the equation of the tangent line. But that's the function. That's what f of x is equal to. So that means that f of 0 is just plug 0 into that thing. You're going to get 1/2 the quantity e to the 6 minus 1. If we find f prime, that's going to be the 1/2, and then we'll get 2e to the 2x plus 6. That was really hard to say. Which, you know, would simplify, but the important thing is we need f prime of 0. So if we plug in 0, we just get 1/2 2e to the 6th, which is like an enormous slope, e to the 6th. This thing is insane. It's like almost vertical at this point. And then we would just write our tangent line, which is y minus the y value, f of 0, equals the slope, f prime of 0, quantity x minus 0. There you go. Let's take a look at the next part. We want to find a closed form, which means no summations involved, for the derivative of f of x times e to the 4x. We already figured out f of x. I don't know if when I was originally writing these, I thought you were somehow going to get to this without doing that. Who knows? F of x we found was this. So we're really just finding the derivative of this. Before I find that derivative, I'm just going to distribute the e to the 4x because it just makes everything a little bit easier. So that'll be 1/2 quantity e to the 6x plus 6 minus e to the 4x. And now it's just, you know, just find the derivative, right? So we got 1/2 You get 6 e to the 6x plus 6 minus 4 e to the 4x. And then you can distribute the 1/2, and you will get 3 e to the 6x plus 6 minus 2 e to the 4x. I mean, it's really not that bad, I don't think. Let's take a look at the next part. Find the area of the region bounded by f of x and g of x equals 4 minus 5x minus 2/3 x squared. All right, I'm going to go to the calculator, do the work, then I'll come back and just kind of write it up. Okay, so we're trying to find the area of the region bounded by f of x, which we've already figured out. We're not going to put in the summation because the calculator doesn't deal with that really well going to infinity. And then g of x. So let's add a graph page, and we'll go from there. So graphing. So f of x we have figured out is 1/2. Whoops. So it's really annoying in the calculator, in the graph page, if you hit tab, it graphs instead of, getting you out of a template. I find that very annoying. E, so it has its own button, e to the 2x plus 6, and then, minus 1, press enter. So that's our first function, and then g of x is going to be 4 minus 5x minus 2/3, so I'm going to use the right arrow instead of tab, and then x squared. Actually, I don't know, on the handheld it might be different. On the computer, definitely hitting tab when you're graphing will take you out of, will just graph the function, which is super annoying. I'm going to press enter. All right, so I need to get a better picture of this to be able to really do the problem, so I'm going to zoom out. So menu, option 4, and then option 4 is to zoom out. You can kind of click anywhere. So here we can see everything that we need to see. So I'm going to press escape. I'm going to find some intersection points. That's menu 8 on 4. Click the first graph. Click the second graph. We can see our intersection points. So I'm going to do two different things here. One, I'm just going to use bounded area. So press menu, option 6 to analyze the graph, and then option 8 is bounded area. It gives you this warning. I should probably just change my settings, but I'm not going to. I don't really think it matters. I know that eventually that'll probably bite me, but I'm going to click. It kind of leaps to the point. So click for the lower point, just drag, click for the upper point, and then I'm going to, so everything's on top of each other right now. I'm going to arrow onto it, click and drag, and so I'm getting 65.8698 or 65.870. I'm going to show you another way that you can do this in case you want to do it on the home screen, which is where I kind of prefer to do these things. All right, I'm going to press, arrow over the first one, this negative 8.312. So this is what we have to write down. So control menu, control and then menu, that's this button and then this button. And then option 5 is to store. I'm going to store that as A because it's the smaller value. Then go to here, negative 1.48, whatever. Control menu. Option 5, I'm going to go with B. Okay, now I'm going to add a calculator page, which is doc 4 and then option 3. And on the calculator page, I'm going to do an integral. So that's shift plus. I want to go from A to B. And now what I often do is, like, I know one of them's F1 and the other one's F2. I know that if I have them in the wrong order, I'm going to get just the negative of the correct answer. So I'm not really going to think about it that much. I'm just going to do F1 of X minus F2 of X and then dx. Since I got a negative, I know that the correct integral is actually F2 minus F1. But because you're just doing it on the calculator to get your own answer to put it on paper, it doesn't really matter which one you do. I mean, technically you should always try to do it correctly. But anyway, these are our values, so I'm gonna go back to the handwritten stuff and finish off this part. Okay, so the values that we got, I'm just gonna pop this up here. We know that f of x was this. We had to figure out when f of x equaled g of x. We found those values, which we store as a and b. And then we wanna write the integral that we're doing. You can write in terms of f, g, a, and b. I definitely recommend that. And then the value that we got on the calculator was approximately 65.870. All right, let's take a look at the next question. We got the graph of f prime shown above. We're going to use it to answer the question. Determine the x-coordinates of the relative extrema of f of x. This is weird because it just says determine the x-coordinates of the relative extrema, like not classify them. But I mean, that's fine. So we need the zeros of this thing, right? So we're gonna need to know what this is. So I'm gonna use point slope form, and the ordered pair I'm gonna use is -1, 1, and then the slope is down 3 over 1, so -3. So 1 minus 3 quantity x plus 1. We have to set that equal to 0, and then solve it. So subtract 1 divided by -3, you get x plus 1 is 1/3. Subtract 1, you get x is -2/3. So that's one of the critical points. The other one is at 1, and then this one is definitely at 3.5. So we can just kind of write our answer here. F of x definitely has relative extrema at x equals -2/3, x equals 1, x equals 3.5. Because f prime of x equals 0 there, that seems weird. So I mean, just for myself, I'm going to classify them, but I'm not going to write it down. Anywhere f prime is going positive to negative, we're going to have a relative max. Anywhere we're going negative to positive, we'll have a relative min. So these 2 points are going to be relative maximums. And then this point will be a relative minimum. Didn't ask you to classify them though, so you don't have to do that. Let's look at the next part here. Determine the x-coordinate of the absolute maximum of f of x on -2 to 4. So this is interesting because we're just asked for the x-coordinate, not the value of the function. And we don't know what to start with, right? Like, do we know that f of -2 is 0? Is it 10? We have no idea. So we're just going to use displacements as we go through. So let's kind of import some values. We knew that that was -2/3. So the first part here, we have a triangle. It's 1 plus 1/3, so 4/3 is its base, and 1 is its height. So I'm going to kind of do the math. You get 1/2 4/3 times 1, which is 2/3. So this area right here is 2/3, positive because you're above. The next triangle is 2/3 and 1 for its base, so that's 5/3. And then the height is -2, so we're going to do 1/2 5/3 -2. And so that'll give us -5/3. So that's the area of this triangle. This next region I'm going to break up into 2 triangles and a trapezoid, I guess. The first one is just 1 by 2, but half of it, so that's 1. Here I'm going to use the area of a trapezoid, so it's 1/2 1, and then 2 plus 1, so you get 3 halves for this guy. And then this is 1/2 by 1/2, so it's 1/2 times the base is 1/2, and then the height is 1. So 1/2 times 1/2 times 1. So overall we get 1/4, that's this. And this other triangle is exactly the same, but below the axis, so we'll say -1/4. All right, so we got all this. What was the point of this? I'm just going to count displacements or sum up displacements as we move across. So I'm going to do the integral from -2 to -2/3 of f prime, which gives us 2/3. Then I'm going to do the integral from -2 to 1 of f prime. And so that's 2/3 plus -5/3, which is just -1. Then I'm going to do the integral from -2 to 3.5 of f prime. That should say f prime, not f of x. I'm not going to fix it. That gives us, we're at -1, and then we add 1, which gets us 0. We add 3 halves, we add 1/4, so 6/4 plus 1/4 is 7/4. And then we're going to finally do the integral from -2 all the way to 4. We're at 7/4, and we're going to subtract 1/4, which takes us to 6/4 or 3 halves. So whichever of these is the biggest number gives us the biggest positive displacement, which gives us the absolute maximum, right? So 7/4 is definitely where it happens. So we're going to say the maximum of the integral from -2 to x of f prime of t dt is 7/4 when x is 3.5 on the interval from -2 to 4. Therefore, the absolute maximum of f of x on that interval is at x equals 3.5. We cannot actually find the value. We just know that that's true. Okay, that's the entire problem set. I hope this was helpful, and good luck.